Welcome to the first video on this channel. Let us begin by solving these two integrals. So you see here, this is a definite integral where you have x on the numerator and sin x plus cos x by the denominator side. So we know the property, we are going to use this property to solve this. So the integral from a to b of f of x dx is equals to integral f of a plus b minus x. So you add those lower limit and upper limit and subtract the x term from it. So this is the property we are going to use. Let us apply it to this question. So let I equals 0 to pi by 2 x by sin x plus cosine x dx. This I can also be written as 0 to pi by 2 minus x by sin x plus cosine x dx. As you can see, the denominator term remains the same. This is because we know that sin the sin pi by 2 minus x is cosine x, and same thing applies for cosine, where cosine pi by 2 minus x is sin x. So we do this, we get this. And now we add these two integrals. Let's add these. So we get 2i equals 0 to pi by 2 x plus pi by 2 minus x by sin x plus cosine x dx. So this is it. Now these two terms get cancelled. So we get I equals 1 by 2 0 to pi by 2 by sin x plus cosine x dx. And again we can take the constant term outside. So we get pi by 4 0 to pi by 2 1 by sin x plus cosine x dx. So this is the same question which is over there. All I have to do now is to solve this integral and plug in the answer here to get the answer for this question. So let's move on to this. So if you see here, the denominator has sin x plus cosine x. So how can we integrate this? We are going to introduce new sine and cosine terms in order to simplify this. How are we going to do it? We are going to multiply this by 1 by root 2, the denominator. Since we multiplied 1 by root 2 here, we also have to multiply the whole integral by 1 by root 2. Now let me multiply each terms individually to get an expression like this. If you recall that sine pi by 4 is equal to cosine pi by 4 equals 1 by root 2. We are going to be using this here, and also sin A cos B plus cos A sin B equals sin A plus B. We are going to be using these both here. So we have sin x here, we write it, and 1 by root 2, we write it as cos pi by 4. Okay, and the next term we write sin pi by 4 cos x and dx. Now we brought this expression into this form. So now let's simplify. So 1 by sin x equals cosecant x. So let's replace this here. So now we are going to integrate this.
I wrote the previous step here. So the integral of cosecant x is the negative natural logarithm of cosecant x minus cot x. So here we have to integrate this. Let's do it. So 1 by square root of 2 remains outside, and we have negative. So this is the expression we get. So whenever you integrate a term like this, you have to make sure you divide with the derivative of this. So the derivative of x plus pi by 4 becomes 1, so we don't need to write that here. So we have this. Now we have to substitute upper and lower limits and find the difference between upper and the lower limit of this expression. Let's do it. I just simplify the whole expression and I rearrange these terms to get this expression. So now let's substitute each values to get the answer. All the trigonometric values required for this question are written here. So I'm going to substitute it. We have this. So we're going to use this property to simplify this. So we get showing negative here. And this is the answer for this. Let's plug this there. And this here is the final answer to this question, and this is the answer to this question. Thanks for watching.